Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. Today we're going to be talking about paragraph proofs, okay? And for this course, we will primarily be working with two-column proofs, which we have already seen before. However, it is good to know how to write paragraph proofs as well. Paragraph proofs are used in higher level mathematics as well as to show that a particular conclusion cannot be proved true or can be proved false. Okay? So there's not much to this except for learning how to write the paragraph proof out. So let's just go ahead and look at our first problem. For sample problem 1, guys, okay, the given here is that angle O is 67.5 degrees. Another given is that angle P is 67 degrees and 30 minutes. They want to prove that angle O is congruent to angle P. Well, we could do a two-column proof here, but today I just kind of want to go over the skill of being able to write this out, okay, in a paragraph form. So in a nutshell, what happens here is you got to look at both of these angles, and you got to remember from the skills that we already know that if we have 30 minutes, isn't that half of a degree? Right? So the answer here would be, since there are 60 minutes in 1 degree, 67.5 degrees is the same thing as 67 degrees and 30 minutes. Since angle O and angle P have the same measure, then they are congruent. You don't have to write it exactly the way I wrote that, okay? However, you do have to have all of the information. All right? I'll let you write that down for a second, and actually give me 1 second. Okay, the question was, if needed, do we have to put this happened because right angle theorem, or straight angle theorem, or congruent angle theorem? The answer is yes. Whatever you would put in the two-column proof, you are allowed to put in a paragraph proof, but it's more in a sentence, quote-unquote, paragraph form. You know, this isn't a true paragraph. It's only 2 sentences, but we say paragraph proof because we explain everything more in words. That's why for most people, a two-column proof is better and is easier because it's just a statement. Okay, why is that statement valid? But here you actually have to use your words to describe it. Sorry. Okay, does that make sense so far? All right, let's continue, guys. Okay, number 2. Given is the diagram as shown. They want to prove that DBC, angle DBC rather, equals angle E. Yes, sir. Yes, sorry. Thank you, sir. This is D right here. Thank you, sir. Okay, that is D right there. So what do you guys think? How would you think you would use this one? And this one, math is going to be used a lot, okay? You're gonna be able to use some words, but you're going to have to use some math. What math do we know here? Yes, sir. That's exactly correct. So if we go ahead and just use that frame of mind, that thought process, that yes, according to the diagram, angle ABC is a straight angle. Therefore, 2x plus x has to equal 180 degrees. Well, 2x plus x is 3x. That equals 180. If I divide 3 to both sides, I get that x equals 60 degrees. And then you can say, since angle DBC equals 60 degrees and angle E equals 60 degrees, the angles are congruent. If you wanted to make it even better, you could say due to the congruent angle theorem, which states that if 2 angles have the same measure, then they are congruent. So again, I'm not trying to complicate things. I'm not trying to make your life more difficult than it is in this class. I just want you to understand that you can prove things with words in addition to column proofs. Not too bad, right? Okay. May I continue, gentlemen? Thank you. Yes, sir. Hold on, let me go back. You're asking, well, you first have to prove this part. There's no ifs, ands, or buts about that. You have to prove that x equals 60. Once x equals 60, you know the placement of x, it's angle DBC. Since you know that DBC is 60 and angle E is 60, you could say angle DBC is congruent to angle E due to the congruent angle theorem. Okay? Or you could just say, since DBC equals 60 and angle E equals 60, the angles are congruent because of the definition of congruency. Does that make sense? Thank you so much for your honesty and for your questions, as always. All right, gentlemen, let us continue. For number 3, given is that angle 1 is acute. Another given is that angle 2 is acute. They want to prove that angle 1 is congruent to angle 2. This is where paragraph proofs really help you out. Now just think about it, guys. Don't make a mountain out of a molehill. Is there any way to prove this? No, there's not a chance on this planet that you can prove this. I don't care what kind of mathematician you are. You'd have to go with a protractor and actually measure the angles. That's the only way to prove this. Okay? But this conclusion cannot be proved. If angle 1, for example, is 20 degrees, and angle 2, for example, is 35 degrees, then they are both acute but not congruent. This is an example of what's called a counterexample, which is used to prove that a conclusion is false. So unfortunately, you cannot just simply say, oh, you can't prove it. Why? But if you give me an example called a counterexample, okay, right here, then you can. Does that make sense? Yes, sir.
So you can't say because not enough information given.
You could say because not enough information is given to start with, but then you're going to have to give me a counterexample. So you could say not enough information was given. For example, angle 1 could be 40 degrees and angle 2 could be 89 degrees, which makes them both acute but not necessarily congruent. No, thank you. Awesome question, as always. Okay. How about, yes, sir? No, I wrote the parentheses. This is an example of a counterexample to teach you guys what a counterexample would be. Whenever you use an example to prove something false or not provable, that is called a counterexample. Thank you. Great question. How about example 4 here, guys? Angle D is 90 degrees. They tell you that it's 90 degrees. You know me, I'm crazy for labeling. I like labeling things. So that's 90. Angle E is obtuse. I spelled it obtuse, but we're not talking about our abs. It's obtuse. Sorry. Okay. It's obtuse. They want to prove that angle D is congruent to angle E. How about this one, guys? Sir. That's exactly correct. This conclusion can be proved to be false, okay? Or you could say that this is a false conclusion. Since angle E is obtuse, it's much greater than 90 degrees. Since angle E and angle D have different measures, they are not congruent. And if you have a congruent sign with a little line through the middle of it here, like this, that just means that it's not congruent. Okay? And these seem simple, and they are, but that's because you guys are already learning the terminology. I'm very proud of you. that make sense? Any questions on 1-6? Sir? Is there a way to do a 2-column proof? Yes, yes, but it's actually going to be a lot longer. If you see something like this that you can immediately know, I could just give a counterexample and I can be done with it right now. Why go through the hassle of a 2-column proof? I know the 2-column proof is not the favorite thing of most students. So if there's a way to get around it, you know, mathematically, do it, my brother. Sir?
This is the test. Are we going to have the choice to do a paragraph proof or two-column proof or
That's a very good question. On the tests and quizzes, 98% of the time I'm going to tell you to do a 2-column proof. If you want to do it in paragraph proof, I will allow it, but I'm going to tell you right now, sometimes when there's 6, 7, 8, 9 different steps for the 2-column proof, you're going to be writing a dissertation. It's going to be a half a page. So it would behoove you to use a 2-column proof. Where it really benefits you or behooves you to use a paragraph proof, like I just said, is when you're proving things that cannot be concluded or that cannot have a conclusion, or that the conclusion is false, that cannot be proved. That's usually when paragraph proofs are most essential. Okay? Thank you so much. Great question. And that's it, my friends. If you would now please open up your 1-7. We're going to knock 1-7 out right now. And I'll give a pause here so you can get your stuff ready. Okay, guys. Now, let's move on to 1-7. This is also going to be a relatively quick and easy lesson. However, there's a lot of vocabulary that we have to really, really go over and understand. Okay? This is actually going to start you off on real heavy proofs. So please pay attention. Okay, deductive reasoning, my friends. Deductive reasoning is basically how we do proofs. It's a system of thought in which conclusions are justified by means of previously assumed or proved statements. Every deductive structure contains the following 4 elements. Number 1. Undefined terms. Okay? You're going to have terms that are undefined that you're going to have to define. Number 2, assumptions known as postulates, which are unproven assumptions. Okay? Theorems are proven assumptions. Postulates are unproven assumptions. They're still valid, they work, but they haven't been proven yet, really. Number 3, definitions. And as you know, definitions state the meaning of a term or idea, which are reversible. Okay? Definitions are reversible. And we'll talk about that in a second. And the 4th part of deductive structure, or of proofs, are theorems and conclusions. That's what wraps everything together. That's what ties it all up together. Okay? Theorems and other conclusions. Theorems are what really make geometry go round and round. Now, as stated before and stated once again here with big bold letters, definitions are always reversible. And when you reverse a definition, my friends, it's called the converse. Okay? So definitions are always reversible. Are theorems? No, not always. Sometimes. Are postulates? No, sometimes. But are definitions reversible? Yes. They are always reversible. And it is called the converse. That doesn't necessarily mean that they're going to be true, but they are reversible. So let me show you an example of that, if I may. For example, the definition for a midpoint is reversible as such. First, I'm giving you in red, it's called the conditional statement. The conditional statement is basically your definition. Okay? That is what's called a conditional statement. That's what starts everything off, a conditional statement or definition. And the definition of a midpoint, as you know already, if a point is the midpoint of a segment, then the point divides the segment into two congruent segments. That is the definition of midpoint, and I know that you guys know that. If a point is the midpoint of a segment, then the point divides the segment into two congruent segments. Now, if you notice in blue, I have the converse statement. And remember what we just finished talking about. The converse is the reverse of the definition, or the reverse of a conditional statement. So the conditional statement is the definition as normal. The reverse or the converse statement is exactly what I just said. It's the reverse. So for example, for this guy, if a point divides a segment into two congruent segments, then the point is the midpoint of the segment. Now, these are reversible because they're both true. Okay, the definition of the midpoint is the definition. That's the conditional. You can't change that. That is the conditional. But I can reverse it into the converse. And all I did was literally reverse it. I took this part and I put it at the back. And then I took this part and I started out the converse with that. Okay? Does that concept make sense to you guys? You can reverse it. Where do you know where to reverse it, Mr. Morrow? The then. The then cuts things up. The first part of the then is the hypothesis. Okay? That's the guess. And then the second part of the then is called the conclusion. So when I put the conclusion in front of the hypothesis, that is called a converse statement. That is the reverse of that definition. Okay? I know you guys are super excited today. It's an exciting lesson, but just hang in there with me, please. We're almost done. Okay? Now, let's continue. Some definitions must be reversed in order to complete a proof, depending on the given facts and what they are trying to prove. So sometimes you have no choice but to use the converse. Okay? Sometimes you have no choice. Now I know I just said this already, but I'm going to repeat it because I want to make sure that this really drives home with you guys. Notice that in the above statement, okay, the above statement is in the form of if P, then Q, where P and Q are called declarative statements. Such a sentence is called a conditional statement, hence why I said it was a conditional. Or an implication. That basically means that you're implying something. You don't need to memorize that that it's an implication. I just wanted to let you know, in case you see that in a question on the test or a quiz, that you know that implication and conditional statement are the same thing. If P, then Q. The if part is called the hypothesis. The then part is called the conclusion. Okay? The if part, that's before the then, that's called the hypothesis. The statement after the then is called the conclusion. And if you have an if P, comma, then Q, it also reads P implies Q, because the statement P is leading to the conclusion of Q. Okay, it's all about logic here. But I can symbolize that with this. P, and I call it a double arrow Q. If you ever see this on a question, on a quiz, on a test, on an SAT where you're going to see it sometimes, please note that all this means is that if P, and then this arrow is the then Q. Does that make sense? You with me here, guys? Yeah? Okay. May I continue? Okay. Thank you, gentlemen. I promise we're almost done. Now, the converse of if P then Q is, as most of you have already figured out, is if Q then P. Think back to the midpoint example that we had. We just reversed the hypothesis with the conclusion. So when you're talking about a converse, you're putting, once again, I know I'm repeating myself, but I want to make sure this really drives home. When you do the converse of a conditional statement, the conclusion part now becomes the hypothesis. And the hypothesis now becomes the conclusion. So therefore, the converse of if P then Q will always be if Q then P, which is how we can reverse definitions. Does that make sense? All right, guys, last page, and then we'll do some examples together, okay? Last page of learning for today. You guys have been great. Thank you. Like I said, I'm not ashamed to say it. I know this is not the most exciting lesson today. There's not much math going on here, and I understand that. So I'm with you, and I thank you for your dedication and your awesome behavior. Okay, guys. Now, theorems and postulates, again, I've already stated this, are not always reversible. Something is reversible if and only if both the regular or the conditional and the converse are both equal. Okay, that's why definitions are always reversible. For example, if two angles are right angles, then they are congruent. That's true. We know that. That's called the right angle theorem. However, can we say that if two angles are congruent, they are right angles? No. I can have two angles that are each 30 degrees. They're not right angles. I can have two angles that are each 145 degrees and 20 minutes. They're both congruent, but they're not right angles. So you've got to be really careful with what you can flip, okay, or what you can actually converse. Because you cannot have a converse always for theorems and postulates. Sometimes it works out. But for the most part, remember that definitions are the ones that can always be reversed. Now, the flow of the proof looks like this. You first have an input, okay, or a fact, such as angle 1 is a right angle, and angle 2 is a right angle. Then you have the conditional theorem, which is if two angles are right angles, then they are congruent. That's the theorem, okay? The conditional, that's going to be the definition or the theorem. And then you have your output or conclusion, which is angle 1 must be congruent to angle 2. So that's the way you want to train your brain to think and flow through proofs. There's always going to be an input. That input, my friend, is usually the given. Okay? The conditional is going to be the theorem or a definition. And the output is the actual proof. That's what you're proving. That's your conclusion. So again, if I tell you the input, angle 1 and angle 2 are both right angles, then using the conditional, well, if two angles are right angles and they're congruent, then that means we've proven that angle 1 is congruent to angle 2. Okay? Hopefully that makes sense to you guys. Now, let's see. Let's see what we got here. Let's do a couple little samples. Yes, sir. Before the sample problem, I have a question. Yes, sir. Oh, okay. You are on fire, brother. Let me go ahead and read it out, and then you can give me the answer. Thank you so much. Okay. State the converse of each of the following statements and tell whether the converse is true or false. So my conditional statement here. If an angle contains 90 degrees, then it is a right angle. Okay, my brother, you said you have the converse for this. Fantastic, man. The converse is exactly what my boy said. If an angle is a right angle, then it contains 90 degrees. Absolutely. That is true. And that's always going to be true when you're talking about definitions. Yes, sir. That's exactly correct, my brother. Converse is literally just flipping. The original statement, this was my P. Sorry. This was my P, this part. And then after the N, this was my Q. So my conditional is if P, then Q. But just like you said, my brother, now we're switching. Now if Q, then P. And not always are they going to be true, but in this particular case, it is true. How about B? The conditional. If Mary received a B on her history test, then she passed the test. What would the converse be? Yes, sir. Excellent, my brother. The converse would be if Mary passed her history test, then she received a B on the test. Yeah, that's false. If she passed, she could have passed with a 70, right? And that's a C. She passed, but it's not necessarily a B. Does that make sense, my friends? All right, guys. We're going to wrap this up, and then we'll use the rest of the class to do some problems together. Thank you very much. I hope you learned a lot, and have an amazing day. Bye-bye. Bye-bye.